Hey, this is Mr. James. In this video, we'll be talking about how to solve equations by taking square roots. Square roots appear very often in mathematics, such as when using the Pythagorean theorem, remember a squared plus b squared equals c squared, when solving equations involving area and perimeter, when working with projectile or free fall motion, such as throwing something in the air or playing a game of Angry Birds, and many other applications. Now, any equation involving a squared term, and possibly also a linear term or an x all by itself, is called a quadratic equation. The key to solving a quadratic equation is to first isolate the variable, that x squared we need to get by itself. And then we'll use a square root to finish solving. It is important to notice that all the steps we're about to do involve using inverse operations. So a quick refresher on what are inverse operations. Now, an inverse operation is an operation that undoes or cancels out another operation. For example, addition is an operation. So if I said maybe I'm adding a certain number plus x, to undo or cancel that out, I would subtract the same number. So addition and subtraction are inverse operations. Similarly, let's say I want to multiply by some number, okay? Multiply or times. The inverse of multiplication is division, okay? Because if I multiply and then divide by the same number, in most cases, I'll get back to my original number. Exponentiation, or raising something to the second power, also called squaring, is also an operation. And we've learned to undo, or the inverse of squaring something, is a square root, right? For example, if I took a number like 5, and I squared that, I would get 25. The square root of 25 is 5. So we can see that squaring and a square root are inverse operations. They undo or cancel each other out, and that's going to be important as we solve these four equations here. Let's start by looking at this first equation here. It says x squared equals 4. Now, before I said that the key is to first isolate the variable, that x squared. And in this case, it already is. X squared is by itself on the left-hand side of the equation. The only thing left to do here is to get rid of that squared using inverse operation, which, remember, we said is the square root. And so I will take the square root of both sides. The square root of x squared, well, again, those are inverse operations, and so we're just left with x. Those operations undo each other. And the square root of 4, well, we know the square root of 4 is 2, because 2 times 2 is 4. In the next problem, we have a squared plus 7 equals 8. Now in this one, the a squared is not isolated on the left-hand side. There's also this plus 7. So we'll solve this the way we know how, by using inverse operations. To get rid of that plus 7 on the left-hand side, we will subtract 7 from both sides. Again, subtraction is the inverse of addition, and whatever we do to one side of the equation, we have to do to the other as well to keep everything balanced. So, plus 7 minus 7 leaves us with just a squared on the left-hand side, and 8 minus 7 is 1 on the right-hand side. Okay, well, now we've got a squared equals 1. Now the a squared is isolated. I'm going to go ahead and take a square root. Remember, the square root and the square cancel each other out, leave us with a. And, of course, I've got to take a square root on the other side as well. And the square root of 1, well, 1 times 1 is 1, so the square root of 1 is just 1. At this point, I bet you can try the next two problems on your own. Go ahead and pause the video and try these next two problems and find a solution. Please make sure to pause. The answers will be up in 3, 2, make sure you try these out first. Alright, let's take a look. In this first one, we have 3x squared equals 54. Now that x squared is not isolated yet. We've got this 3 right here. And this is 3 times x squared. So, again, using inverse operations, we will have to divide by 3 on both sides. 3 divided by 3 on the left-hand side, well, 3 divided by 3 is 1, and 1 times x squared is just x squared, so those cancel each other out. Okay? And 54 divided by 3 is 18. Now at this point, the x squared has been isolated. We can go ahead and take a square root of both sides, and we're left with x equals, well, the square root of 18 won't have a whole number answer. There is no whole number square root of 18. So we've got a couple options. We could just pop this in the calculator and get a decimal approximation. Okay, I'll use my squiggly equal sign because I'm saying it's approximately equal to, and if you pop that in the calculator, I'm getting 4.24. Make sure you're getting the same thing, 4.24 if you round to the nearest hundredth. Or I guess you could simplify the square root. So the square root of 18 breaks down into the square root of 9 and the square root of 2. The square root of 9 is 3. The square root of 2, I have to leave that under the square root. And so x could also equal 3 square root 2. Again, these are representing about the same number. It's just whether you want to put it in the calculator and round or simplify the square root. So either way, x equals 4.24 or x equals 3 square root 2. In this last example here, we've got 9b squared plus 10 equals 73. Now again, in this one, the variable b squared is not isolated, so we'll have to get that by itself out on the left-hand side. We'll treat this like any other equation and start by subtracting 10 from both sides. And so we're left on the left-hand side with 9b squared equals 73 minus 10 is 63. Then since this is 9 times b squared, again the inverse operation is going to be to divide both sides by 9. Okay, and then left with b squared equals 7. Now that b is isolated, I'm going to take a square root of both sides. The square root and the square are inverse operations, so I'm left with b equals, well, the square root of 7, again, I could pop this in a calculator, use my squiggly equal sign to say it's approximately equal to 2.65, if I round to the nearest hundredth. Or if I wanted to simplify the square root of 7, well, no perfect squares divide 7, and so I'll just have to write that as the square root of 7. So either b is approximately equal to 2.65 in the calculator, or it's exactly equal to the square root of 7. Now we can always go back and check our work by taking our solution, for example, 1 in this problem right here, and substituting it back in for a. So I'll write that over here, 1 squared plus 7 equals 8, and then evaluating both sides of the equation. 1 squared is 1, 1 plus 7 is 8, and so we have 8 equals 8, and we know that we've solved that equation correctly. Or in the first problem, we had x is 2, so we could say that 2 squared, by substituting it back in for x, equals 4, and 2 squared is 4, 4 equals 4, perfect. But there's one little hitch here. There's actually another number that would also work as an answer, besides just 2. What if I put in the number negative 2 for x? So I'll have negative 2 squared equals 4. Well, negative 2 squared is going to be like negative 2 times negative 2. We know a negative times negative is a positive, so negative 2 squared is actually positive 4. And so actually, negative 2 also works in this equation. The same thing happens over here. There's another answer besides just 1. If I put in negative 1, okay, into this equation, so negative 1 squared plus 7 equals 8. Negative 1 squared, negative times negative is a positive, so negative 1 squared is just positive 1 plus 7, which is 8. So negative 1 also works as a solution. This actually happens whenever you take a square root of both sides of an equation. Because we've got x squared here, or a squared, or x squared here, or b squared here, it's not going to matter whether our solution is positive or negative. If I put in a positive number, great. If I put in a negative number, well, a negative number squared always becomes a positive number. So whether or not my answer is positive or negative doesn't matter. When it's squared, it will always become positive. So for my solution to this first one, it's not just x equals 2. It could also be x equals negative 2. So I'll put x equals 2 or negative 2. In the second one, a could be 1, but a could also be negative 1. There's actually a symbol we can use to signify that a number could be both positive or it could be negative. It's called the plus or minus symbol, and it looks just like this. Now we've learned that whenever we have a squared term, such as x squared, and we take the square root of both sides of the equation, it's not going to matter whether our solution is positive or negative. So we can use that plus or minus symbol as soon as we take that square root and write that our answer is plus or minus 2. It's not going to matter whether it's positive or negative because it's going to get squared anyway. Same thing in the second problem over here. Okay, when we take the square root, we can write the plus or minus symbol, and our final answer is a equals plus or minus 1. Again, because a is being squared, it's not going to matter whether our answer is positive or negative 1. Same thing applies down here. When we take that square root, our answer could be positive or it could be negative, and it won't affect whether the solution is correct or not. We've learned that when there's a squared term, and we take a square root of both sides of the equation, it's not going to matter whether our solution is positive or negative. Again, because when you square a negative number, it becomes positive anyway. So we can use that plus or minus symbol as soon as we take the square root to show that our answer could be positive or it could be negative. So in the first example here, x could equal plus or minus 2. That's the symbol we use. Same thing in the second example. Once we take the square root, we can add that plus or minus symbol, and our answer could be plus or minus 1. Again, because if we plug that back in, or substitute it back in for a, it's being squared. It's not going to matter if it's negative. Same thing with these problems at the bottom of the page. It's not going to matter, once we take that square root, whether our answer is positive or negative. And this last one, again, once you take the square root, not before it, but once you take that square root, it doesn't matter whether our answer is positive or negative. So we can add that plus or minus, and b equals plus or minus the square root of 7. Both will work if you plug it back in for b. One last thing I want to leave you with before we wrap up this video. In real-world geometry problems, our answers are not typically negative. So we're running around doing all this plus or minus stuff, but in geometry we're often actually not going to use that. Think about it. If you had a problem such as this first one, x squared equals 4, and this problem was something about, I don't know, the number of gallons of water in a pool, and you had the answer is going to be plus or minus 2 gallons. Can you actually have negative 2 gallons of water in a pool? That doesn't even make sense. So for that, our answer would just be water. Or can you really have a length, a side of a square? That problems involving length, area, volume, things like that. But I am showing you this because when you move on to more algebraic kinds of problems, the plus or minus will be important. For example, a problem about temperature, right? You could say that the temperature is plus or minus 2 degrees, positive 2 degrees, and negative 2 degrees, both Fahrenheit or Celsius. That makes sense. Or if your answer was about money, you could have plus or minus $2. It makes sense to have $2, and also negative $2 means you're in debt. So those kinds of problems, more algebraic problems, make sense to use plus or minus, and you'll see those eventually. But when you're working in a geometric context, things like meters, inches, gallons, negative values just don't make sense. Well, I hope you've learned how to solve equations involving squared variables called quadratics by taking square roots. Remember to go back, rewind, pause, and predict with this video whenever you need to help you learn. Good luck!